I mean to kill you in 1 minute, Ned. Or see you hanged in Fort Smith at Judge Parker's convenience. Which'll it be?
I call that bold talk for a one-eyed fat man.
Fill your hand, you son of a bitch!
What'd you say? Oh, you're talking to me all wrong. It's the wrong tone. You do it again, I'll stab you in the face with a soldering iron.
I'm ready. Okay, you know, I was riding home today. I had my children this weekend, Friday, Saturday, and Sunday. And I took them home in the morning. They do school at their mom's. They can do it here too, but she keeps them for the first few days and I get them last. Right now. Anyways, but I was on my way home, and usually this time of day, this time of year, 13 Mile Road is, it's, well, I'll show you. It's, the sun is right down the middle of the road. Wait, that's game capture. Okay, and then boom, and then boom, right? Yeah. No, I opened one. See, I had to make it a little bigger because my cell phone takes poopy pictures, you know. But this is the way it looked. And, you know, it just looked like an orange ball, you know. It was, see, this is, I mean, it was right in my face, but you know how cameras, they just can't do it. And I could stare right at it. It was, if there had been any sunspots, I probably would have seen them too. It's just really weird. Got some more here. I gotta try to, okay, I think I gotta go back to the old size. No? Yeah, see all photos. Come on, what's up? Wait a minute. Okay, here's one. It was just peeking over the trees. I wish it would do it justice, because it was just, I was in awe. I couldn't stop staring at it, even when I got home, especially I'm doing something on the sun right now. And that's just, so you try to make it a little bigger and you just wash it out completely. Let's try another one here. I took about 6 or 7, you know. Got a little effect there. Yeah. I was moving. I was trying to drive and take a picture of the sun. Could get hit. But hey, I got my priorities right. It was beautiful. I just couldn't stop. I'm just like, that's the sun. And everybody else was staring at it too. I was noticing everybody just stopped what they were doing, staring at that big orange ball in the sky. You don't see it like that very often, you know. Close encounters of the starry kind. Red dwarf passed within 0.8 light years of our solar system. Now that's getting pretty close to what we're talking about. Shoal's star was discovered in 2014, but appeared to have an odd motion. Astronomers traced its path through the sky and found it was moving away. They found it came closer than any known star 70,000 years ago. It passed so close that it passed through the outer Oort cloud, which is a theory of comets. Our current nearest star is Proxima Centauri, around 4.2 light years away. It's another red dwarf. The Shoal star came 5 times closer, but is now 20 light years away. Our solar system had a close encounter with another star 70,000 years ago, research has revealed. So we're not that far off after all. The recently discovered star passed just 0.8 light years away. They're not really given much else on it. Astronomers discovered the star's flyby by tracing its movement through the sky and found it would have passed within the outer Oort cloud of comets. Dr. Eric Mamajek, an astronomer at the University of Rochester who led the study, said that it is unlikely the star would have caused much disturbance to the scattered icy comets that orbit the outermost reaches of the solar system. However, he said it raised the possibility that other close encounters with stars in the future could have far greater impact. He said, using that, I like the way they use the word impact. They want to make you think of it crashing into us. He said, using the best available astrometry, our simulations suggest the probability that the star penetrated the outer Oort cloud is 98%. While the flyby of this system likely caused negligible impact on the flux of long-period comets, the recent discovery of this binary highlights the dynamically important Oort cloud perturbers may be lurking among nearby stars. Shoal's star was first discovered in 2014 by Rafe Dieter Schultz. Of course, I know nothing I see nothing. But unlike other stars around it, it appeared to have an unusual motion in the sky. A team of scientists from the U.S., Europe, Chile, and South Africa used observations of its motion to trace back its trajectory. They found that the star is moving away from the Earth at great speed and came alarmingly close 70,000 years ago. They calculated that the star, which also has the catchy name WISE J 072003.20084651.2, passed 5 trillion miles away from our sun, 0.8 light years away. So that'd be a load of dust 0.8 miles from the sun. I don't think it would have much of an effect. But seeing that they're saying that it can get that close, it's not far off from one entering the sun's heliosphere. This close, it would have been impossible to see the star from Earth with the naked eye. It was far too dim. Scientists believe it is an active red dwarf that is about 8% the mass of our own sun. It is part of a binary system and is accompanied by a brown dwarf, a failed star that was too small to spark life, even when at its closest to Earth. Schultz's star should have been 50 times fainter than what can be normally seen with the naked eye. Instead, the star would have been visible with a telescope, technology far beyond our ancestors 70,000 years ago. Says them. However, the star may have occasionally flared and become brighter for a few minutes. For any of our ancestors who glanced upwards during such a flare, they would have seen it in an area around the Big Dipper. Astronomers who work published in the Journal of Astrophysics Journal Letters calculated that Schultz's star's path would have taken it through the outer areas of the Oort cloud. And they have a little diagram of the hypothesized Oort cloud. This is where they believe long-period comets come from, and short-period comets come from the Kuiper Belt. This is what they say, mainstream.
I never drink wine.
Cluj, Albiolulia, and Brasov. It took him 15 months to complete this task, during which he discovered hundreds of original documents, manuscripts, chronicles, treaties, manifests, old drawings, paintings, and facsimiles. Strange place for that word, for his extraordinary contribution. He was elected in 1880 member correspondent of the Academy in the historical section, and was offered the position of librarian, archivist. Nevertheless, he was very poorly paid and lived almost in poverty. Until 1884, then he received the position of translator for the Army General Staff. In 1884, he published The Revolution of Horia in Transylvania and Hungary, 1784-1785, written on the basis of 783 official documents. Banned in Hungary, work which was the last word in documenting the terrible tragedy of that section of our national population, the uprising which had preceded the French Revolution. In 1885, he published Monuments for the History of the Country of Fagaris. I think, isn't it strange that we just don't ever pay attention to the East? You know, as if the East wasn't there. But they were. They were huge. Maybe Rome was Romania. If you think about it, it's possible. Treating in detail the real ancient history of the Romanians in Transylvania, compared to their present situation under Austro-Hungarian rule. He deplored the fact that once falsehood is introduced in history, it is very difficult to uproot it and even to discover it. During this same year, he started work on his great masterpiece, Prehistoric Dacia, and in order to gather material for it, he departed in 1887 on a scientific trip towards Italy. He passed through Croatia, where he studied in the library of the Academy of Agram all the collectors of original manuscripts regarding the Vlachi, or Romanians from southern Croatia. Then traveled through the villages of these Romanians, settled near the river Kulpa, but already losing their nationality. From there he entered Istria, where he visited the local Romanian villages, from where he collected important material about language and traditions. He then traveled to Dalmatia, staying at Ragusa for some time, where he studied and copied documents from old archives of the Ragusan Republic. From Ragusa, he traveled to Rome, where he spent 7 months studying in the library and archives of the Vatican. They're only going to let people see what they want them to see. After which he traveled through the Neapolitan countryside, Apulia, Calabria, and Sicily in order to become conversant with the customs and the way of life of the peasant population of Italy. He returned to his country, Romania, with a significant historical and ethnographic material. Between 1887 and 1897, 6 volumes of the documents regarding the history of Romanians, 1199-1345, collected and accompanied by notes. And in 1893, he wrote the study, The Religious Independence of Romanian Metropolitan Church of Elba Iulia. In 1894, he voluntarily withdrew from public work, refused a new, very good position, being content with minimal means of subsistence. I always admire people like that. People like that have my admiration. They're real people. In order to have the peace and quiet needed to finish his monumental work, Prehistoric Dacia. In 1895, though, he took a commission, war ministry, and wrote The Glorious Princes of Famous Captains of the Romanian Countries. After 1897, he decided to dedicate all his time to Prehistoric Dacia. In his own words, I always had in my sight the history of the entire Romanian element, in whatever countries it found itself in ancient times, either constituted in bigger states or organized in districts only, provinces and national countries. Tired and sick, he retired in 1899, even from the continued publication of the historical documents, but continues to publish short studies on different subjects in parallel to his great work. So in 1901, he published Military Romania, in the study The Origin of and Historical Importance of the Romanian Cavalry. And in 1902, he was named a member or correspondent of the Romanian Geographical Society. In 1904, he published a study, The Chronology, the Formation and Unity of which go back into the most remote times. In 1906, he wrote an unpublished study regarding the military history of the Romanian people from the most remote times until the 18th century. And in 1909, he published 2 very important studies. The War of 1330 between King Carol Robert of Hungary and Basarab, the Dam, the equivalent of king or prince, ruler, or of the country, a Dam, but it's King Ludovic I, the King of Hungary, and Vladislav Basarab, the Don of the Romanian country. Finally, he devoted himself wholly to Prehistoric Dacia, which took him 40 years in all to complete. Only to make it ready for print took him the last 11 years of his life, dedicated to assiduous work. But alas, he died before seeing it published. That's terrible. I will try my best not to bore you, but it sounds like it's going to be really good. If we Romanians have resisted the floods of invasions, if we exist from far beyond the Dniester in the east to Istria, Switzerland, and little Valahia of Bohemia in the west, from South Poland in the north to Athens and the islands, archipelagos, and the islands in the archipelagos in the south. It is not only because the Roman colonists were brought here by Trajan. Our essence is Proto-Latin. We were the ancient Arimi, as they were called in remote time. One of the principal tribes of the Pelasgians, one of their branches, were Remi, who founded Rome. That's what I was going to say. It's very possible. Romani of today, I always thought, because Russia and that area, Romania, is so vast, it would only be logical that more people would live there because it was bigger. One of the principal tribes of the Pelasgians, okay, we got that already. Romani of today already existed. From here that they penetrated far to the end of Asia, the north of Africa, to Spain and Denmark. As in all of these regions, it can be observed that their ancient populations were branches of the same people, who dwelt and had their center especially in Transylvania and Ottenia. Then Susanu begins his work with with the
Quaternary epoch.
the Paleolithic period. His first chapter is about the first inhabitants of Dacia. He continues with a description of the stone-fashioned tools and of the animals which lived then and there.
Felis Spela.
Felis Spela, the cave lion, Bos Oros, or Bos Primigenius, shown on the Moldavian coins and coat of arms, the woolly bison, and
Cervus Megasaurus.
Cervus Megasaurus, all of which are still mentioned in Romanian folk poetry. He speaks about the Neanderthal in Cro-Magnon man and about the Neolithic invasion of Europe, affirming that here at the lower Danube, and especially in the countries of Dacia, the fact is certain had formed and coagulated the great and powerful center of the Neolithic population in Europe. He then treats extensively and competently the prehistoric ceramic of Dacia and its ornamentation, precursor to that of Troy, Mycenae, Central Europe, and the Aegean cultural world. In the following chapter, Denisut treats the prehistoric monuments of Dacia, especially the heroic Pelasgian tumuli and the tumulus or tomb of Achilles in Leoche Island, which is none other than the Serpent's Island in the Black Sea. He describes in detail the temple of Apollo on his same island, also called the island of the Hyperboreans. There you go. I knew sooner or later I was going to run into them. Speaks about its later role, establishes which was the country of Apollo and Latona, Leto, and describes the people of the Hyperboreans, generally shepherds, who were Pelasgian of this region. He proves that after Apollo's cult had moved southward, this island and temple were consecrated to Achilles' shadow. Finally, he presents the Romanian legend about the divine origin of the sacred monastery, representing this same temple of Apollo. The author treats the commemorative mound of Osiris, about Osiris' expedition to the Ister and his wars with Typhon in today Oltenia, and writes about the giant furrow of Novak. And that's what we're going to get into here. You know, for them to have spoken Latin, I don't know. I mean, it just doesn't sound right. Why would they speak Latin? And why is it that no one speaks it today? They didn't speak Italian. See, there's something fishy about that. Something being covered up, I think. And I'm going to read this little series here, and we're going to try to get to the bottom of who the Pelasgians. I just wanted to give you this little recording. I'll be working on it. I'll still be working on the Saturn theory, and lots more coming up. All right, I'll talk to you soon. And this guy, he wrote the book Prehistoric Dacia. He unveils a past almost entirely unknown, a glorious past for Dacia. For the people who lived in these places, who Densusenu proves are our direct ancestors. He knew profoundly the classics and mastered their language, and read them in original, so that he gives the right interpretation of texts formerly appeared with the wrong meaning, owing to the lack of knowledge of the translator. It is incredible and defies the imagination how he finds, to the last detail, in Romanian legends and ballads, ancient deeds described in ancient texts, starting with Homer himself. His argument is solid, well-grounded, extremely well-informed. He was accused of advancing hypothesis.
He proved the millenary continuity of the Romanian people.
He proved the millenary continuity of the Romanian people and the conservative force of our nation. Which is a bit odd, because when I looked up the word millenary, all it says is women's hats. That's strange. It must be military. The general essence of his theory is, in short, the following. Densusenu starts from the prehistoric man and gradually reconstitutes the biggest empire known to the ancient world, the Pelasgian Empire. He shows the extraordinary role played for the human civilization by this empire, owing especially to the deified kings Uranus and Saturn, and their wives Gaia and Rhea. He proves, it can't be said otherwise, that the entire, but absolutely the entire mythology, so-called Greek, was born in the mountains of Dacia, between Buzet, these words, I'm sorry, I apologize, they're not words that I'm used to coming in contact with.
Butzau and the Iron Gates.
Butzau and the Iron Gates. The great temple of the world was on the peak of Amol in the Busegi Mountains. He proves that a principal branch of these Pelasgians spoke a language called by him Proto-Latin,
which gave birth to Latin and the Neo-Latin languages. He shows how tribes of this empire, the basis of which he believes to have been mostly religious, composed mainly of shepherds and later by metal workers, descended and founded Troy, Messene, and Rome. Interesting. He tries to recreate the customs, belief, and language of these peoples and manages to explain countless historical facts which so far had been unclear.
Its later establishes which was the country of Apollo and Latona, Leto, and describes the people of the Hyperboreans, generally shepherds, who were Pelasgian of this region. He proves that after Apollo's cult had moved southward, this island and temple were consecrated to Achilles' shadow. Finally, he presents the Romanian legend about the divine origin of the sacred monastery, representing this same temple of Apollo. The author treats the commemorative mound of Osiris about Osiris' expedition to the Ister and his wars with Typhon in today Oltenia, and writes about the giant furrow of Novak. And that's what we're going to get into.
And critically, it is obvious at the North Pole of Jupiter, where one can see at least 15 counter-rotating cylinders. We asked Dr. Scott for his interpretation of the mysterious electron acceleration in the Jovian aurora.
When you think about it, Birkeland finally, many years after the poor man died, his work was absolutely substantiated by the probes that we sent up into the Earth's atmosphere, upper atmosphere. Birkeland was right that the Earth's auroras were indeed caused by electrical particles, charged particles coming from the sun. Everybody knows that now, but this idea of spiraling, the twisting, the magnetic flux ropes that twist like ropes. The question I should think that they would be asking themselves, and it apparently has never occurred to them to do that, is why is the twist? What causes the twist? Everything in the sky twists. I mean, galaxies rotate, planets rotate, the sun rotates, everything twists, moves, but nothing sits still. Nothing flows like water in a pipe, just straight. Everything is twisting. Everything is in a tornadic kind of movement. And why? I would submit, according to the model that I developed, that is the basic, fundamental property of a Birkeland current is this twisting, this counter-rotation. And that's where all of these motions come from. Apparently, they have observed electric fields out there. Mention of the word voltage, and we're talking about, and they actually put in here 400,000 electron volts, and they said electrons are accelerated in the Jovian atmosphere at energies up to 400,000 electron volts. Well, if it's an electron, that means it's gone through a voltage drop of 400,000 volts. That is a whale of a voltage. I remember being completely laughed at by certain astronomers who have attended our conferences in the past, and there's nothing, no voltage like that out there. I mean, where's the battery? We can't have it. Where did you get the battery of 400,000 volts? Well, and now all of a sudden they see it. And now they're mystified. And had they listened to us and been more cooperative with us maybe years ago, more than just the 2 or 3 years since I published this model, but in years prior to that, and they would have maybe not been quite as surprised as they are. I mean, everybody should realize that the way you get charged particles, for example, a prime candidate, an electron, to accelerate is to put it in an electric field, to put it through a voltage drop. By definition, a voltage is a measure of the potential, the electrical potential energy a positive particle has at a certain point in space. So if you say the voltage at this point is 400,000 volts, that means it's just like a billiard ball or a bowling ball sitting on top of a 400,000 foot mountain. Okay, so now all of a sudden the bowling ball rolls down the mountain. By the time it gets to the bottom of the mountain and has fallen through that distance, man, is it moving. It converts its potential energy, which is voltage, into kinetic energy, which is 1/2 mv squared, 1/2 the mass times the velocity squared. So that even though it's velocity squared, that's still a pretty high velocity. So that's where they're getting these tremendous velocities from. And I think their problem is they don't know where the voltage comes from. I realize, and I think everybody who's interested in plasma cosmology realizes, that strong, very, very strong cosmic currents come not from a battery. There is no 400,000 volt battery out there in space. What there is an induction process when a conductor, and for the word conductor, substitute plasma, because plasma is a very, very good conductor. When a column of plasma moves through a magnetic field, or a magnetic field moves across a plasma, if there's relative motion between plasma and a magnetic field, you will induce a current. And given the magnificent size of these astronomical size of some of these magnetic fields and these plasma fields out there, yeah, there's a tremendous potential, and I use the word as a pun, tremendous potential. It's an induced current that gives electrons this tremendous acceleration. If we here in the electric universe are correct, then the entire cosmos, and specifically our solar system as being in the cosmos, is fed by electric currents, Birkeland currents, or at least force-free field-aligned currents, or some type of currents. We know they're out there. We know they're voluminous in their effect. If you think so, and the other end, the other side of the capacitor, to the bottom end of the resistor, and now we have what's called a parallel combination of a resistor and a capacitor. That is a good starting point, I think, to think about an object, whether it be the sun or Earth or Jupiter or any other object that is under the influence of an electrical force, electrical currents that go through it. Let's not argue about the sun. We know the sun has those kinds of currents entering and leaving. And the same thing is true about Earth, because we know about the Birkeland current that comes into the North Pole of the Earth. So we know that happens. But if you think about the gizmo that's in the middle, whether it's the sun or the Earth or Jupiter or whatever, as a little parallel combination of a capacitor and a resistor, you can realize that as the current goes down through the resistor and makes that plus minus, plus at the top, let's say if current comes in at the top, plus at the top, minus at the bottom across that resistor, that same voltage is applied to the capacitor. Now, if you apply a voltage to a capacitor, that capacitor will charge up. It will have charge. And so can a body like Earth be charged? Yes, because it's within the current input that the Birkeland current puts in the North Pole. Actually, Birkeland currents carry currents both ways. There are these cylinders, and you can get current going down in the middle and up on the outside. Bodies can have charge. They do have charge. And they may have a net charge if it's hooked up, as I just described, with across a resistor through which a current is flowing. And there's a voltage drop across the resistor. There will be a voltage drop then across that capacitor. And that means the capacitor will have a net charge.
These themselves form. Some people have said that science is a method for asking questions of nature. And if that's true, then we can say the Big Bang supporters are people who won't take no for an answer.
2 or 3 decades, the Big Bang theory has become increasingly more and more speculative. One expects from a scientific theory definite predictions which can be tested by observations. If the observations disprove the predictions, that theory is supposed to be disproved, and it should be modified or abandoned.
In science, we work from observation, from empirical observation that starts in the here and now and works outwards and backwards. The Big Bang starts from mathematical formulas, deductions that start from the beginning of the universe and to try and predict it forward. This is the same mathematical approach, mathematical deductive approach, that led 2,000 years ago to the development of the Ptolemaic universe. The universe, of course, which was Earth-centered, with the planets going around the Earth, with the stars in a crystalline sphere. What these theories have in common is that they try and derive what should be the universe based on what perfect principles we can develop, what God should have made the universe to look like. And then they try to fit the universe into that perfect framework.
However, what has happened over the years is that whenever observations have come up which don't agree with the predictions of the Big Bang theory, the theory adds an extra assumption which is not at all tested, which is not at all resting on conventional physics, and simply assumes that that must be true.
The problem with that is that develops myth, not science. It develops a religious faith in which nothing in the real world, in the observable world, can contradict the faith in this structure, in the Big Bang. This undermines the entire scientific enterprise. The reason science has been valuable to human beings is because it allows us to predict nature in such a way as we can use nature in a predictable fashion in technology. To abandon this approach, which has served us so well, and to go to the idea that we can deduce, we can read the mind of God, as Stephen Hawking says, and deduce from perfect mathematical principles what the universe must be, is to abandon the scientific method. The Big Bang has handled the cosmic microwave background. It's a very good example of how this process works.
Want to put it in. So you look and it's there, so you put it in. That's that. It isn't an explanation.
First of all, the temperature of the microwave background, basically the amount of energy, was not what the Big Bang supporters had predicted. They had predicted a much higher temperature.
So it was 50 degrees Kelvin that was being compared against the 2 to 5 degrees Kelvin from the steady state universe. Now, this may not sound like much, but in energy density, where we measure the absolute differences, the differences is 4 orders of magnitude, 10 times 10 times 10 times 10 difference. So there is an enormous difference between 50 degrees Kelvin, a rather poor indicator of what is happening in the universe, and 3 degrees Kelvin.
When you read the textbooks, they don't tell the whole story. They don't present these figures, 5 greater than 5, 7, 50, and then that they did find 3. So that's very strange how the textbooks, they hide a part of history.
And the temperature of the Big Bang proponents was rapidly readjusted from 50 degrees to 3 degrees.
But their theory could be adjusted so that the temperature becomes a free variable that it could be just taken as what was observed.
We have an observable universe which is made of stars, galaxies that are not very distant, and that's all, because the 3-degree radiation, I would even think that it might be local. Still not. And going beyond that is, I think, a wild extrapolation, whatever it is. And the physics that we could imagine to be existing there is based on nothing, because we have no test for it.
What was dark matter? Dark matter was some matter that we don't understand, we don't know what it's about, we haven't observed it, but it isn't ordinary matter, so it doesn't enter into our equations about the light elements, and we can't see it as stars. But dark matter is 90 or 99% of the mass of the universe. This is what we call in science a fudge factor. When your equations don't work out, you just write in this little plus something. Well, in this case, this was a humongous fudge factor because it was 90 or 99% of the universe.
And you have to not only postulate that this matter has to exist, but it has to exist in quantities much greater than the amount you see of ordinary matter.
And I should emphasize that people have looked for dark matter. People have looked for dark matter since it was proposed years ago. WIMPs, little particles that are supposed to be floating around in space, that we should, in theory, be able to observe as they pass through the Earth. Dozens of experiments have looked for these particles. Not one has been found. Again, this should be a contradiction. The way science works, you make a prediction, observation contradicts it, the theory should be rejected. But that hasn't happened. And the epicycles don't end. There's a problem with dark matter, even theoretically. Even though we can't observe it, there's still a problem with it, which is dark matter slows down the expansion of the universe. So the length of time that the universe has existed, the length of time since the Big Bang, should be shorter than what's indicated just by linear expansion. The problem is it's too short. The prediction of the cold dark matter theory is that the universe should be about 8 billion years old. Well, that's a big problem. We can determine the age of stars in our own galaxy, in the oldest globular clusters, both based on very well confirmed theories of the nuclear evolution of stars and spectroscopic observation. And the stars in our galaxy are 13 or 14 billion years old. So it's very embarrassing to have 14 billion year old stars in an 8 billion year old universe.
In addition, they went into dark energy. Now, why did dark energy come in? Because if you take the present value of the cosmological constant and the cosmological constant which came out of inflation, you find that they are not the same. Not only they are the same, but you have to find that the difference lies in something like 108 orders of magnitude. Now, can you imagine a physical theory getting the answers wrong by a factor 10 to the power 108? Yet, the Big Bang cosmologists very coolly accept this and simply put in another epicycle by saying that there is a dark energy which has changed over the time by this factor. So we have to accept that.
Dark energy is some force, again, unknown on Earth, unpredicted by any theory that we have validation of here on Earth, that causes an acceleration of the expansion of the universe. So as the universe is accelerating, and it's older than appears on the basis of the dark matter theory, and it's 15 billion years old. So we solve the problem of the age of the universe by hypothesizing yet a third completely ad hoc epicycle dark energy. So now we have a universe which is 70% dark energy, 28% dark matter, and only 2% matter that we can observe through our telescopes and here on Earth. Epicycle is being piled onto epicycle. And in the process, what we call the predictive power of the theory is fading away to nothing. One of the most destructive features of the methodology of the Big Bang is that it conveys the idea that only experts can understand the universe. Only people versed in extremely complicated mathematics can understand the universe. That if dark matter, dark energy appear to be incomprehensible or even nonsensical, it's because you don't understand the mathematics of these complex equations. This is, of course, the argument of the emperor's new clothes. If you can't see the emperor's new clothes, then you must be either stupid or incompetent.
So this
Solar electrical effects. The sun's surface is carpeted with complex magnetic fields. Only electricity can produce magnetic fields, therefore the sun must be understood in terms of electric circuits. Where are these circuits and what creates them? And what sustains them? Plasma physicists know that the movement of different types of plasma past one another will generate currents in the plasma. When you get back to first causes, we do not know. We don't even know the right questions to ask at this stage of our ignorance, I would suggest. Sunspots are an embarrassment in the thermonuclear model. They have powerful magnetic fields with the same polarity spots clumped together. Now, normally the same polarity magnetic fields push one another apart. However, the magnetic field here is a signature of the Birkeland currents piercing the photosphere. And the pinch effect means the magnetic field is very intense in sunspots. They are drawn together because parallel currents attract. It's as simple as that. Ampere's law. Their darkness, structure and behaviour have required great ingenuity in attempts to explain them, yet they remain mysterious. I asked the question, does this sunspot penumbra, this is where you can see edge on to the photosphere and look deeper into the atmosphere, or the ionosphere, I should say, of the sun. And I asked this question, does this sunspot penumbra look like turbulent, boiling hot gas? And I would say not. It has structure, it has a motion which doesn't look like boiling material coming up from the interior of the sun. And why is the sunspot dark if the sun is hotter beneath? It should be blindingly bright because we're trying to get that 15 million degrees energy out through this hole which is looking deeper into the ionosphere of the sun. The simplest answer is that the sun is thousands of degrees cooler below. And remember I said stars are formed with cool cores? They're not formed with hot cores. They could never have any nuclear reactions in their core under those conditions. Here we come back to Birkeland. This man was amazing. He wrote, it might be imagined that the interior of the sun formed a positive pole for enormous electric currents. So there's your electric sun. This assumption has the advantage of appearing to give a natural explanation of the movement of the sunspots in various latitudes. This experiment has been repeated back in the 60s, and depending on the current input, those spots move in latitude, which is exactly what we see. So the sunspot movement across the latitudes on the sun is a measure of the changing input to the power input to the sun. In this case, he wrote, the origin of the sunspots must be that the presumptive, more or less insulating photospheric envelope was sometimes pierced by disruptive discharges. I couldn't believe it when I read that. Thus forming great electric arcs. I would say he was the first one to actually tell you what a sunspot is. And that was from his huge tomes called the Norwegian Aurora Polaris Expedition, published in 1902-1903. What do we find today? This is the sun in ultraviolet light, and you can see that we have an equatorial view at the top and a polar view at the bottom. And it has a plasma torus about it, and this is exactly what Birkeland had found in his experiments, that you get a plasma torus, and it's a storage ring, it stores energy. When that energy gets to a certain level, a massive discharge will take place from that torus to the surface of the body, and it follows the magnetic field lines. In the extreme case, when there's too much energy in that ring, it may actually switch to a polar jet. Many stars have polar jets. I suggest that these long filaments in the penumbra are actually electrical tornadoes, thousands of kilometres long. They have bright edges, dark cores and a twisted appearance. And there's a special effects fire here with a helicopter engine above, and fire is injected at the bottom, and you can see the bright edges here and the dark core, and you can see these filaments here. It's exactly what they've got. And bright lightning flecks the tops of the granules. These are the solar granules that we see covering the sun. So the sunspot cycle, you see the sun in X-rays and it is a variable star. It almost winks out at solar minimum, and at solar maximum it is much brighter. And X-rays are a direct measure of electrical activity. The sun is connected to a galactic circuit which is subject to quasi-cyclical change, so that the origin of the sunspot cycle is beyond the solar system. It may be due to alphane waves in the Birkeland currents that feed the solar system, or it could be due to the actual motion and rotary motion of the Birkeland currents past the heliosphere. Seen in X-rays, the Sun is a variable star, and yet the heat and light from the Sun is constant to within 1/10%. An explanation is very important, for it explains why most bright stars shine steadily. And it's not like the 4th of July. An electric sun, this is something that Don Scott pointed out, because he's an electrical engineer and knows this stuff inside out. He said this voltage curve here across the photospheric tufts, those long filaments that we saw a moment ago, is that of a PNP transistor. In other words, this tufted sheath of our sun forms a barrier for protons escaping the sun, because those protons trying to escape the sun have to climb this barrier here before they can go down this waterfall and excite the corona to its tens of millions of degrees temperatures. And beyond here, there's a slight electrical field, just enough to accelerate the solar wind the way we see it. Of course, this then is a regulating mechanism, because just a small shift in voltage up and down here is enough to modulate the power output that passes through these tufts. And that is the regulating mechanism for all bright stars that have a photosphere. That's why they shine steadily in the night sky. There is no regulating mechanism for a thermonuclear model star. In fact, they're the most unstable things you could imagine, because some of the reactions vary with temperature to the 5th power. Here are these strange things called spicules, and Ralph Jurgens didn't shrink from trying to explain these as well. And it turns out that to maintain a steady discharge through that tufted sheath, there has to be a balance between the number of electrons travelling one direction and the number of positive ions going in the other. And these spicules actually provide the material to be ionised in the chromosphere and maintain a steady discharge. There's an analogue in some arc lamps, the kinds of things used in searchlights. They had porous anodes to actually produce this steady arc. Don Scott, this is his diagram from his book, The Electric Sky. It's the solar transformer. The greatest puzzle of the Sun, its magnetic field reversals, is solved. The Sun has magnetic fields induced by a varying DC power input, and so acts like a power transformer with an impressed DC current as well. So all you've got is a varying DC current, which is driving the Sun. Remarkably, once again, here he is, Christian Birkeland proposed that solar magnetism was caused by electric currents induced in the conductive interior of the Sun. Hey presto. He should have got a Nobel Prize, several of them. Solar neutrinos match the no thermonuclear engine inside the Sun. It's not important, but it's just one of the questions that arise. Neutrinos produced in the dense photospheric plasma, because these are pinches, is where the nuclear synthesis takes place. So stars produce their own heavy elements. You don't have to have supernova explosions to do it. A supernova explosion actually distributes the material that the star has already formed. A neutrino count falls when the sunspots reduce the photospheric area. So the higher the number of sunspots, the lower the number of neutrinos, which is what you'd expect if this second point is correct. So we need not assume a change in flavour of neutrinos, whatever that means. In other words, a change in resonant state of the neutrino en route from the solar core, because the reactions in those plasma filaments is much more complex than the standard hydrogen to hydrogen chain reaction would provide. Now, stellar and planetary structure and composition are based upon the erroneous conviction that Newtonian big G is a universal constant. So when I say that this Sun has a heavy element core, of course the helioseismologists would say, but you know, our models show that it hasn't. But they're basing their model on a completely erroneous idea about the amount of matter in our star or any celestial body. If big G is a variable dependent upon the electrical state or the electrical tension in a body like the Sun, then we cannot say what it's made of. We have no way of knowing except by observing material that comes from it. And if the sun is cool, there is a radial internal electric field to be considered because, as I said before, all the positive charges are heavier than the negative charges. So in a gravitational field there would be an offset and a radial electric field, so all celestial bodies behave like electrets. These internal electric fields can actually respond to disturbances and cause the ejection of large quantities of core material. In other words, form planets and moons and so on. The electric sun has a completely different picture. Here we have a cool core, we have an extensive atmosphere and an ionosphere at the top, and at the very top of that ionosphere is this global lightning or electrical tornado system, packed cheek by jowl. Then above that you have the energy flow, and of course it's normal to expect that incoming electrical energy will excite the plasma out here first, and then as it gets into the more dense atmosphere it will exhibit discharge activity. Out here it's a coronal glow, in here it's normal electric arc phenomena. So the energy to heat the electric sun comes externally from the galaxy. The electric discharge becomes intense close to the sun, heating the thin atmosphere of the corona to millions of degrees, and the superheated corona is a familiar glow discharge phenomenon recognised by high voltage engineers. Now we come to the HR diagram. It's based on observations, it's not based on theory. It's a scatter plot, not an evolutionary plot, and the luminosity and colour of a star depends on its size and the current density at its radiating surface. Discontinuities exist. You've got white dwarfs over here, red giants here, and red and brown dwarfs, which are all discontinuous with the main sequence. These are all stars with bright photospheres, so they have that regulating mechanism. Of course, the astronomers got it back to front. If you do a mirror image, then you have a more understandable arrangement where the stars get brighter and bluer as you increase the current density, so that you get this straight line curve, which is exactly what you'd expect. Red stars have to expand. That's both red dwarfs and red giants. They're stars which are not collecting enough electricity to satisfy the discharge, so plasma adjusts. It's like a living thing almost. It adjusts to its environment. And so it expands the anode sheath to collect enough current. And some of those anode sheaths are monstrous. You know, Betelgeuse, if that star was in our solar system, its photosphere reaches out to the orbit of Jupiter. White dwarfs, on the other hand, may be normal-sized star, but they have no bright photosphere. Their upper atmosphere is in direct contact with the plasma of space. They have only a faint white corona. Imagine if the sun's photosphere turned off, you would see this white envelope, very faint, but very white, very high temperature in appearance. So stellar evolution is a fairy story. This is V838 Monocerotis. This erupting star transformed itself over a period of months from a small underluminous star, a little hotter than the sun, to a highly luminous, cool supergiant star undergoing rapid and complex brightness changes. This was the quote of the article describing it. The transformation defies the conventional understanding of stellar life cycles. It's a very complex story. I've been through it, the theory of it. So here's a red giant. This is actually Betelgeuse. It's 500 times the size of the sun, and it has a hot spot. You've got to ask yourself, you know, what's a hot spot doing on a red giant star? What happens is as that envelope expands, the electric field grows stronger because it's trying to collect electrons from space. But on the other hand, positively charged particles, in other words, its stellar wind, are accelerated more strongly the other way. So you have this anomaly where these cool stars have the most powerful winds known. And if the stellar wind is being boiled off, so to speak, this doesn't make any sense at all. And Betelgeuse sports a hot spot, and I've suggested it may be above one of its poles because one of the Alphane circuits shows that one of the connections of the electric circuit is to the poles of the star. So we may be staring at one of the poles. Giants and dwarfs. The usual story is that stars consume their fuel and change to giants or dwarfs. The story is complex, unverifiable, and regularly contradicted. This is another version of the HR diagram there. And astronomers are perpetually astonished by unexpected changes in stars. This is a white dwarf system. Sirius B is the white dwarf, and Sirius A, you'll see an optical light here. Sirius A is very bright in the sky, and Sirius B is almost invisible, and it's a faint white, so-called white dwarf. Now, if you look at it in X-rays, it's the reverse. Here's Sirius B, it's brighter than its optically bright partner Sirius A. This is what you'd expect, where the discharge reaches into the ionosphere directly of a star. The X-ray output is high, the visual light output is low. There's nothing special about that. It can be an ordinary star, it's just that its partner may have usurped most of the current. It's supposed to be a collapsed star at the end of its fuel. But how can an old and a young star be together? Because here you have an old and a young star, so to speak, under the conventional ideas, together. A white dwarf has no bright photosphere. Its white light and X-rays come from an intense corona. Here's the different star types, and I've shown how I think they would look. A red dwarf is actually quite large. In other words, it's like a red giant in miniature. A red dwarf was discovered, and the astronomers decided that it was putting out too much light for what they assumed was a dwarf star. So they said, oh, it must be a pair of red dwarfs of exactly the same size and power output. I suggested, no, it's a single red dwarf. It's just much bigger than anyone ever expected. Main sequence star, it is covered with photospheric tufting, tufted anode and a controlled discharge. Blue giants are a large star under high electrical stress. Red giants are a normal star under low electrical stress, and it develops a bloated glowing plasma sheath. A white dwarf is a normal star in direct contact with space plasma and has low luminosity. Talking about brown dwarfs, if a brown dwarf gets close to a very bright star, the bright star is at a higher potential than the brown dwarf. That brown dwarf will actually switch off as a star and become a comet. It switches from being an anode in the discharge system to being a cathode, and there are quite distinct differences. Now, if the Earth, hypothetically here, if the Earth was a satellite of a brown dwarf, that radiating shell would be quite enormous. It could have all of the satellites of that object, that small star, orbiting within that envelope. That whole radiating envelope puts energy on the surface of any orbiting planet equally on every square metre. So that you would have no seasons, no day and night, and you'd receive ultraviolet light. This refers to what Dwarf was talking about the other day with the earliest memories of mankind. It suggests that we were in this situation, and astronomers in recent years have come to the conclusion that this is the more likely place for life to thrive. Where we are now is much more precarious. So brown dwarfs don't hang out with stars because electrically it's impossible. The other thing is that these brown dwarfs, unexpectedly, they flare. They throw material off occasionally because they've got no means of controlling their discharge other than to get rid of material, matter, charged matter. So that any satellites of these brown dwarfs gets occasionally drowned in water, an atmosphere, and also solid materials to cause layering on them. Brown dwarfs flare and deposit layered minerals on their satellites. There's a few more logical leaps involved in the electric universe, and I'll just go through a few of them. I asked the question, is gravity a weak electric dipole-to-dipole force between distorted subatomic particles? And this refers to something that Velikovsky said to me when I visited him, and also to Ralph Sansbury's view that all subatomic particles have an orbital structure, a resonant orbital structure. And as Ralph has pointed out, magnetism then is also an electric dipole-to-dipole force due to transverse distortion of electrons or protons accelerated in an electric field. If so, the electric force is the only force necessary in physics, and this goes back to the way classical physics operated by trying to reduce the number of forces and ideas. And quantum effects imply that all matter has a resonant electrical substructure. information and energy can be stored and transferred via these matter resonances, and that has significance in biological systems too. So astrophysical and biological coherence requires universal, near-instantaneous electrical interactions. All of the so-called spooky quantum things are no longer spooky if we accept this idea. We have a return of the ether. We must have particles to be able to transfer the energy and the forces through so-called empty space. Empty space, I suggest, is full of neutrinos. Neutrinos are the lowest energy state of matter. They exhibit vanishingly small mass. They're composed of subtrons, which is what Ralph called them. They form electric dipoles, that is the neutrinos, in an electric field, and each dipole rotates in the electromagnetic field of a light wave. That ties the speed of light in a vacuum to the moment of inertia of a neutrino. And neutrinos may reintroduce cause and effect to radioactive decay. At present, it's a purely statistical phenomenon. The other thing is that it also solves the difficulty of the so-called annihilation and creation of matter in particle accelerators. You cannot do it, but if the neutrinos are the substrate, they can accept energy and become a particle and its mirror particle. I don't use the word antiparticle because there's no such thing. It's all matter, normal matter. I put these few slides on the end because there was discussion about Venus and the transfer of charge, and I think it's important because it returns Velikovsky's gauntlet to him cordially. Velikovsky argued that planets change orbits, exchange thunderbolts, and quickly settle into peaceful orbits. Now, rapid settling after chaos defies Newton's laws, which, of course, that was the argument levelled against Velikovsky, which for more than a two-body gravitational system are chaotic anyway. So the astronomers have yet to explain why we have a stable solar system. So astronomers simply ignored the gauntlet flung down by Velikovsky. Then we have Anthony Peratt and the convergence of his work with ours some few years ago. And he showed, globally, petroglyphs show to a high degree of confidence that within human existence the Earth has suffered stupendous electric discharge phenomena from the heavens. And that's a picture of one of his papers. Now, if we accept Velikovsky's gauntlet, we need to look at Newton's law of gravity again and just have a think about what it really means. You'll notice there that G, I put its dimensions there just to show that it does include mass, and if mass is a variable, then we have a problem. It is simply assumed that G is the same for all bodies in the universe. In other words, the universal gravitational constant, and that was an assumption. Stellar and planetary structure and composition is based upon this premise, but if mass is a variable, can it explain cosmic pool? The book over there is by one of the Thunderbolts team, C.J. Ransom, The Age of Velikovsky. Of course, MOND is the latest buzzword in gravity theory, the modified Newton's dynamics. I've suggested that we can have electrically modified Newtonian dynamics. And I won't go through all that business there, you can see it on my website and so on. But the upshot is that the radius of the orbit of the planet is proportional to the mass of the planet if you keep the orbital energy constant and you assume the sun's G is constant, and I think that's a fair assumption. If the mass doubles, the orbital radius must double to conserve orbital energy. Now, I said earlier that all planets and stars and all celestial objects will form an electret. In other words, you have positive poles facing inwards and negative poles facing outwards. So it sets up an internal electric field. The planet acts like an electret. And any free electrons would tend to drift towards the surface. Like a subatomic particle under the stress of an electric field, the internal electrical stress modifies the apparent mass of the planet or star, and therefore its gravity. Exchanging charge at the surface through lightning, etc., changes the mass or gravity of a planet. And there is evidence for that. Coronal mass ejections, large ones which strike the Earth, actually change the rate of spin of the Earth suddenly, and then it decays back to its original speed, which is diagnostic of a change of the moment of inertia of the Earth by some means which hasn't been explained. Comet accelerations also. Cometary displays are an obvious electric discharge phenomenon. Any body on an eccentric orbit about the Sun will experience discharge activity. The discharge will cause apparent non-Newtonian acceleration, and this is well known with comets. They're very hard to predict their precise return because of them. And this is because the mass of the comet is changing, something that's not taken into any account. However, gravity is still the operative force, but here we have a feedback mechanism which can modify orbits. So, changing planetary mass. The closer the encounter between two planets, and the more powerful the charge exchange between planets, the greater the orbital adjustments. It seems an efficient mechanism for collision avoidance and spacing the planetary orbits apart, which may explain one of the reasons why we survived Velikovsky's catastrophic scenario. The inner planet reduces its charge polarization, its mass, and the outer planet increases its polarization mass in the exchange. And I ask the question, is this possible? Yes, I believe it is. Because some years ago it was reported that a spacecraft here, the SOHO spacecraft, picked up stringy things, stringy plasma things, arriving from Venus when it was between us and the Sun. Now those stringy things, of course, are recognised immediately as Birkeland currents, and the Birkeland currents transfer electrons from Venus to the Earth. At present it has little or no effect on the Earth because of the distance and the low current density. So there's an intermittent circuit for transferring electrons from the inner planet to the outer when they're aligned with the Sun. The charge transfer is in the correct sense to induce the planets to move apart into orbits having electrical least interaction. Quickly it will appear as though the system operates according to Newton's laws with no sign of recent instability, and that was the problem that Velikovsky faced, and it was the question I asked him when I visited him. How do we deal with this problem? And I think this is the answer, or part of the answer. And we come to the Sagnac Award winner, and I consider a great man, a modern Galileo. Dr. Halton Arp embraces a plasma universe. I think it's a very apt photograph. Also, I might say there are a lot of interesting issues raised by Halton Arp's discoveries that fit neatly in an electric universe solution. For example, intrinsic quantized redshift and an increase of mass with time are explained by an electrical origin for particle masses and their resonant quantized states. Because the quasars are ejected from a galaxy, the electrons are tangled up in the plasmoid at the centre of a galaxy for far longer than the neutrons, which can escape because they're uncharged, and the protons, which are heavier. So that quasars are electron deficient initially, which means that all of their energy levels of all their matter will function at a lower level. Their fine structure constant will be different, their redshift spectrum will be enhanced, but over time, as the electrons stream out in those great jets that we see, both the mass increases, but it does so in resonant steps, quantized steps, and the brightness increases because the electrical energy arriving is increasing. And so this explains this very strange phenomenon where a quasar ejected at very high speeds from the centre of an active galaxy can actually slow down and go into orbit about its parent. So this is the quasar mass gain, and you can see this is one of Arp's diagrams of the birth and the development of quasars into companion galaxies. Intrinsic redshift, an increase in mass of subatomic particles equals an increase in the orbital energies of electrons within atoms in the quasar. That results in a decrease in redshift of the quasar. And since subatomic particles are resonant systems of charge, the redshift must decrease in quantum jumps. Now, any explanation for this kind of intrinsic redshift gets over the problems that you face if you try to talk about the medium between us and the quasar, because you cannot quantize, as far as I can imagine, the redshift by anything that occurs between us and the emitting object, but it's intrinsic to the emitting object. A web of circuitry and the electric force connects and unifies all of nature, organising galaxies, energising stars, giving birth to planets, and on our own world, controlling weather and animating biological organisms. In other words, there are no isolated islands in space. Thank you.
We're kind of getting I was getting comfortable there, enjoying it. I was just letting Walt take it away. I didn't plan on playing it for that long. This is not